Here. All right, welcome everyone to Portage County Safety Council. We are excited to have Mark here from Integrated Mill Systems to talk about machine safety workshop, manufacturing safety and productivity inside your organization. Mark brings with him a vast knowledge of safety and health with some great topics and great ideas that I think will improve your company. I'm very excited to hear today's presentation. This is part 1 of 5. So we encourage you to come back to the additional 4 presentations that will be happening weekly over the next several weeks. With that, I won't take too much time sitting here talking. I'm going to turn it right over to Mark. And sir, the floor is yours. Thank you so much for being here with us.
Very good. Thank you, Nick. Thank you, Mike. And welcome to everybody here. Today's presentation, as you said, is part 1 of 5. The 5 parts we're going to do once or every Wednesday for your pre-lunch viewing pleasure here. So here are the 5 parts. We'll talk about societal demands and safety and productivity today. And then that puts the second part into some context. Here's what's happening in society. Society then is laws reflect what is happening in society and what our leaders come up with then to say, well, this is how to address issues in our society. So that would be part 2. So this kind of all builds together and it puts the subsequent part into context of the previous ones. So society, then the laws and standards, here are the rules. Now let's apply these rules to the risk reduction methods. We'll get into some details. Part 4 is going to be engineered controls and safety circuits. We're not going to make you an expert on those circuits, but I want to expose you to the idea that if we're going to use engineered controls, guarding and light curtains and control circuits and stuff like that, what goes into that? I have still clients that just say, hey, let's just put a light curtain on there. Well, what is that light curtain connected to? That'll be part 4. You'll see how involved that is, and relating it to the previous parts. You'll see how the standards affect that and why, in the broader sense, where society is demanding this, and even society, by society I include business as well, so industry. Finally, the last part of it then is, okay, once we install all these great things and everything's working great, how do we manage the inevitable change that will drive challenges to what was installed previously? How do you make sure that what you put in previously is as safe as it was when you put it in? So management of change will be the last part. So those should be the whole thing. So integrated mill systems, and this is, I'll say what this is a tool that we use at Integrated Mill Systems. This workshop is for companies that are sort of grasping it or trying to understand the broader concept of improving manufacturing safety. Where do you start? It's an elephant, and how do you eat this? So the first step is understanding the breadth and depth of this extremely complex and broad yet necessary type of topic. So Integrated Mill Systems, just to introduce you to who I work for today. I've been there for about a year. This is a control systems integrator in Willoughby, Ohio. East side of Cleveland. We do business all over the country and all over the continent, really, and primarily focused in the metals industry: aluminum, steel, titanium, other alloys, and whatnot. From the primary aspect of metal manufacturing to the processing of fixed or solid metal afterwards. They've been around for about 30 years. Have been doing machine safety control systems since the inception of the idea of a machine safety control system. So a lot of experience in this. The nice thing about the concept of control systems and particularly safety control systems is that the standards, the technology, the techniques are applicable across all industries. A gate access control solution in a metals plant is exactly the same in a food plant or a chemical plant. It's even the same engineering. It's the same products. It's exact. You could lift one from one place and put it right into the other. and it would be compliant and completely compatible with those operations. So it's very transportable. When we say integrated manufacturing or integrated safety, this is basically what the process entails. And this is really the framework. This machine safety lifecycle is the framework for which this 5-part series will encompass. We'll talk about standards and all the different standards. There's literally dozens and dozens of them, thousands of pages. But if you boil them all together, this is basically the process. This 5-step process is the machine safety lifecycle. That's what all those standards spell out. The most mature, we're going to talk about safety maturity today. Most mature machine manufacturing corporations, in the world wouldn't even consider anything other than following this process step by step when they put in a machine safety solution or try to mitigate risk in manufacturing. These are the steps that are followed. So these are the, this whole thing laid out here in general. What alignment of, I don't know why this, it's a graphic, weird, PowerPoint. It blips and goes away. Anyway, but integrated mill systems does the entire machine safety life cycle for clients. So part 1 today is these are the elements of what we're going to talk about today. Now, I've done this previously. We do this workshop for companies on a regular basis that are trying to understand. Usually when we hear something like, we don't know what we don't know, this is where we start, is with this full day. It's all 5 parts we do in one day at a company site. We do it for a cross section of the entire company, from engineering, operations, EHS, purchasing, maintenance, executives, everybody involved in the company, because it does touch everybody and helps them, understand that. So we start off with part 1 here. The societal and economic forces. How did all this come about? What's driving this? What we'll talk about, the technology, the techniques, the standards, the processes, all of that is a reflection of the demand of society to say, here's what it takes. We'll talk about manufacturing safety maturity as well, some of the things that I did in my previous career. And then we'll give you a tool to help measure manufacturing safety maturity. And then there's also the last part of it. How do you justify it? How does investments in machine safety become part of the contribution to the fiscal health of the company? Not just in avoiding safety incidents and the subsequent costs of that, but how do I contribute to manufacturing excellence? How do I get more widgets out the door, or basically run a better factory? So we'll show you how to do all that with some tools. In the chat, there's going to be some handouts available to you. I'll talk about the first one here in the next, just immediately following this. But you'll see this notes D plus V plus S greater than R. That's a little change equation I'll talk about briefly. But in the chat, you'll see a link to a spreadsheet where you can start to take notes, and even take notes during this presentation, jot some ideas down if things come to mind. I'll explain that here in a bit. Then there's the handout that we have for the workshop that covers the entire topic from beginning. It's really the technical aspects of the topic and the regulatory aspects of it. Basically, an outline of the machine safety life cycle. So if for your reading pleasure, or if you ever wanted to provide this to somebody else in your company to say, hey, let's put a light curtain in it. Oh, well, wait a minute, there's a lot more to it. Hand them this document and say, here's how deep this is. So it's an overview of what we're going to talk about here in the coming month. And then lastly, or actually, there's a brochure on what machine safety means to integrated mill systems and what we offer. And then lastly, a PDF of all these slides here as well. So let's start right off here with this change equation. The reason I bring this up is that, a lot of what we're going to talk about here is going to be somewhat different than, I'll say, the, you know what, I might have the different deck. I might have the wrong deck up here. This will work. But anyway, this change equation is something that I was introduced to by a cultural transformation consultant. There's an entire industry of consulting individuals, social scientists that study um, social aspects on manufacturing behavior and attitudes and how to transform them. So one of them introduced me to this pretty neat equation that may help me make a lot of sense. So the way that this kind of lays out here is enterprise risk plus uh, safety and productivity plus a comprehensive roadmap in the form of this D plus V plus S, dissatisfaction plus a vision plus steps to get there. Those are the elements when we, from a psychological perspective, this is what goes into our head to say, can we overcome the resistance to change? So D plus V plus S, all of that combined, if change is going to occur, all of that combined has to be greater than the resistance to change. So in the context of manufacturing safety, you'll see that the elements or ideas here, enterprise risk, safety and productivity, and a comprehensive roadmap. All of those essentially have to be in place to get to that change element. And you'll see some ideas listed below, those a little more specific here. So for instance, if we go to on the far right, commitment to change, or the resistance to change. Some of those may be, you may be experiencing here yourself or some frustration as a safety professional when we say, hey, we need to do some things differently. These are some of the things that might be held up as barriers to say, here's why we're not going to change. Usually I ask the audience, does anybody know what that acronym is at the bottom? And just to cut to the chase, it's one of the most common ones that we hear to say, here's why we're not going to make any different, or we're going to do something different here, is the acronym is, but that's the way we've always done it. And that's typically what we'll hear sometimes too. It's frustrating to say, hey, we haven't heard anybody like this before, but as a safety professional, you got some inherent risks there so far. You wonder, are we just lucky or are we good? But anyway, that's the way we've always done it. If you see the other parts in there too, these are some ideas and things that have been employed in the past. Dissatisfaction part of it, enterprise risk. There's more and more of that builds, but these are the problems. If we've got a safety incident, or there's been some sort of fine or something, or there's issues with you've detected somehow employee morale or union relations, right? The safety and productivity aspect of it, we're going to talk about that next. The vision, what is possible and what is happening today in some of the best in class manufacturers out there. How are they doing this? How are they achieving both safety and productivity? In my experience too, the dissatisfaction plus the vision, when we combine those and we don't have the next steps out there, we end up typically with a stymieing effect. We create this elephant. I've got this dissatisfaction. Yes, I can see the vision, but have you seen this? I don't know where to start. And sometimes it'll stymie, your constituents to say, like, I don't even know where to say, and essentially then nothing happens. There is no change. That becomes an element in and of a resistance to change in and of itself. I don't know where to start. So the next steps, particularly the very first step, is the key to that. So some ideas that you could talk about with as a team to say, how do we get this thing going? A lot of times, in most cases, this topic is covered by external resources, or you bring in external resources to help you with some ideas, trusted resources. There's a 10-step program we can talk about. How do you get started? We'll talk about this SMI assessment shortly too, Safety Maturity Index. I'll introduce you to that next. And then some pilot projects. Key to this whole thing too is executive leadership, or how do you gain executive leadership? How do you garner it? How do you flip the bit in the top leader's head to say, hey, this is an important thing. It's really not a priority. Let's make it a value. And we'll talk a lot about the differences there. So anyway, this change equation, the the handout that you got there are some ways you can kind of take notes and parse this up to say, hey, I've got this dissatisfaction aspect, or hey, I've got this idea for a step, or, this is my vision. Parse that out, and you could use this and kind of build that formula, as you go forward. Okay, so next let's talk about, what's happening in the world and this concept of safety and productivity. I mentioned I've been with Integrated Mill Systems for a year. Obviously, I haven't just graduated from college. I'm not a young man. I've been around for a long time. So I've been in the automation business for about 35 years, 30 of it with Rockwell Automation. One of the roles that I had there, I was in sales. I was a sales engineer there, and invariably in that role, I get, introduced or drawn into, the depths of factories, I'll call it the bowels of manufacturing, and, behind the scenes, to look at applications or, issues or something like that to come up with solutions. So throughout my career, I've had numerous occasions to observe, in-depth manufacturing facilities. And I was always amazed at the significant discrepancy from place to place. You could walk into one place and it's inconceivable to get hurt there. People are following the rules. You're walking through the designated walkways. You've got your PPE on. You may have a safety video. You sign some forms. Everybody behaves, and everybody's got their safety glasses on. And anyway, so you walk through there. It's inconceivable people get hurt. You go right next door, the very next place. Maybe it's the same company, but there's a massive discrepancy between that place and this death trap you just walked into. And I was always amazed, how could that happen? If we've got the same laws, rules, regulatory enforcement, everything's the same, yet literally right next door in the same town, I've got a significant discrepancy of attitudes and behavior and procedures, and basically death trap to a place, that it's inconceivable to get hurt. So, this is something that was of interest. One of the roles I had at Rockwell was global market development for safety for Rockwell. So I was able to get a global view of this idea and this thing, and sort of begin to ask those questions and research it as well, with resources and tapping into experts and really global manufacturing to begin to ask this. And this is basically what it boiled down to. And the short answer to it was the second part of this business goal of a manufacturer: attain a production goal at an acceptable level of risk. An acceptable level of risk. What is acceptable? That death trap versus inconceivable where it would be hurt. And that's basically what this thing boiled down to. I worked a lot with Zurich Insurance out there. Pat McCann, if you guys know him, he works for Zurich. And basically a guy named Cal Beyer, they're one of their former vice presidents, had the way he put it was, what is your company's appetite for risk? And that was really kind of the bottom line as to what was the root of this major discrepancy. So that's what we're going to talk about next. How did that discrepancy come about? As we all know, OSHA is about a little 51 years old now, or 50 years old, almost 51. And with that, with the Williams-Steiner Act, imposed rules, laws. We call them the OSHA standards, but they're really laws. And with that, some obligations for manufacturing. When manufacturing began to employ those rules and laws and say, here's how we keep, people safe, because there wasn't a whole lot of creative solutions on how to do this stuff, it ended up kind of creating a negative effect and a negative impression of safety. Yes, we had some positives: litigation, labor grievances, healthcare costs. People weren't getting hurt, but at a significant cost to the manufacturing. So if I go back to that equation, attain production goals at an acceptable level of risk, production goals being hurt really gave safety a black eye. The demands were still there though. The safety versus productivity, that equation was still there. And what that did was put this dilemma right down at the manufacturing floor. The manufacturing associates, the people running the machines and maintaining the machines, were on a continuous basis having to decide, do I keep the machine running and producing, or do I follow the safety protocols and the solutions that the only thing I have available, which were basically designed to make things safer, but with sacrificing productivity. So continually, moment to moment, scenario by scenario, they had to make that continuous decision. Do I go the safety route or go to the productivity route? And because the charter of a manufacturing facility is to get things out the door, typically productivity won out. So we continue to have this dilemma. One of the things I like to do in the workshop I conduct, I've got a varying variable of how old people are. We got some youngsters in there and some old people on there, but I like to put this picture up there and ask if anybody recognizes it. People my age, we all know this image and know exactly what it is, the Challenger disaster, right? So I was able to, I met and became good friends with the head of NASA safety. He was in charge of all safety launch and space station, and it was after the space shuttle was over that he took over safety, but he does all the tours. But anyway, he was exclaiming to me or telling me about some of the things, the lessons that were learned from the Challenger disaster. And this is common knowledge. These are things that you can read about. You know, the root cause, once that was studied, how did this happen? And as the story goes, the engineers, the day of that launch in 1986, said, don't launch. We're outside the spec. We're outside, it's too cold. Don't launch. There was significant pressure, though, to launch, particularly that day, because what was happening that day, which was vitally important to NASA funding, popularity, public support, all of this was that night. Ronald Reagan was doing the State of the Union address, and he was scheduled to talk to Krista McCullough, the teacher that was on that space shuttle. They were going to talk live from the podium in one of the widest covered television events, in our of the year. Big publicity boom for NASA, and public support was in there. So that was I'll say the productivity pressure for that day. That overrode the fact that we had launched, we shouldn't launch, it's too cold. But here's the big story out of this concept of the normalization of deviance. Where that came from was, and why the people who said to launch that space shuttle that day was that they had launched in the past when it was that cold and even colder, and successfully launched, and there was not an incident. So they decided, hey, the engineers really don't know what they're talking about. We've launched before, it's too important. We'll take the risk here, because the risk was seemingly diminished because of this concept of the normalization of deviance, deviating from protocol, deviating from standards. They've done it in the past. It became, hey, it's okay, So that's where that term came from. Now, the lesson that was learned from that was not quite adopted by NASA, because we had another problem, the same root cause, normalization of deviance. This is the Columbia disaster that happened several years later. Same issue. They had broken off protective tiles on the bottom of that space shuttle in the past, not repaired them. They had the choice. They knew, like, they had an issue, as you know, like the foam covering the fuel tanks broke off, collided with the bottom of the shuttle during launch as it was leaving the atmosphere, and broke the protective tiles on it. They had done that in the past and successfully landed in the past. Thus, normalized that deviation to say, you know what, we're not going to delay the re-entry, the return of this. We're going to do a very expensive spacewalk, risky spacewalk. We're going to repair those tiles. They could have done that. That was an option, but they decided not to, because they successfully landed in the past. Okay, so those are some basic, this concept of normalization of deviance. It's an important concept to keep in mind when we're talking about and discussing things with our leaders, to say, should we change, or should we invest in this stuff? Now, The next big thing, one of the things when I worked for Rockwell became #1 in all this machine safety technology, safety PLCs, light curtains, scanners, safety drives, contactors, all the components. So they were #1 in the world in this. It became a very good barometer to the adoption of the safety technology. So what we saw at Rockwell was a massive explosion in the mid to early 2000s for demand for machine safety products in this. And so we started studying it, trying to understand, what was the root cause or what was leading to this increased demand. So the short answer, right to the point, was cell phones, particularly cell phone cameras, combined with social media, combined with a society with an insatiable appetite for sensational news about bad things that happen to corporations, damages to valuable logos and company image and whatnot. So all of that was occurring because of the cell phone. Because basically, prior to that, if an incident occurred in a factory, there was pretty much very little way for the general public to find out about it because news crews wouldn't roll, to go and take a picture. Hey, we had an amputation, somebody got their arm cut off. But now we've got 1 billion, I'll say, news crews and production facilities right there in your pocket with the cell phone camera. So we had an explosion of, we'll say, transparency. Very difficult to keep a secret anymore what really goes on in a manufacturing facility, particularly some of the more dangerous industries, paper, metals, chemicals, you name it. So there was an explosion of stories like you see on your screen there that wouldn't have existed before. No one would ever have known about this had not been for 1 billion cameras out there. Last year, we, as a society, global society, we took over 1 trillion pictures. We have a place to share those pictures with people with a huge demand for those kind of sensational stories in there. So that demand was the single leading cause of the pressures on executives to say, well, what are we going to do to keep our name out of Facebook and Twitter, and with pictures of a severed body or a severed arm or horrible incidents that occur daily around the world and in this country. So companies started, I'll say, talking the talk, and years later we see, and we actually commissioned a study to try to understand this, a significant discrepancy between the talk and the walk. And you'll see, the results of the study here is that most companies, or half the companies out there, felt like, hey, safety really is a core value at this company. They're doing the talk, but when you look at what was actually being invested in and taken advantage of, there was less than 20% of the companies out there were actually following through with something as well. So that put this dilemma then for this manufacturing associate. The pressure became even greater. Hey, now be safe, now be productive. What am I supposed to do here? I don't have the tools, I don't have the solutions out there. I'm now, the dilemma is even more egregious here. What am I going to do with it? So we went further and did some further studies, looking at this industry as well, and or industry in general. And this is a study that what we call it the Aberdeen Study, or the kind of the executive epiphany. I'll explain this chart here in a moment, but what we were interested in is, was there a correlation between safety and productivity? Now, if we go back to that slide with the scale showing safety, getting things out the door, meeting your production goals versus health and safety. There was like this balancing act, and the perception that the only way to be safer was to slow down or sacrifice productivity. The only way to increase productivity was to sacrifice safety. That was the conventional thought and wisdom for a long time. This study, commissioned in the early 2010s, really showed the real truth behind it, that was just a myth. there's a direct correlation between safety and productivity, a positive correlation. In other words, you'll see here, the safest companies in the world are also the most productive. Now, this is a correlation report. So let me show you kind of what this is. I'll get back to this chart, but the way this is worked out here, we took close to 7,000 manufacturing facilities, provided their data to the Aberdeen group here. And what came out here, they break it down by an aggregate of the top 20, the middle 50, and then the laggard 30s. That's kind of the main scale, the horizontal aspects about it. Let me explain the data here on the right. Let's first start with OEE. Overall equipment effectiveness. This is pretty much the ubiquitous KPI for manufacturing. Basically, how many widgets are we getting out the door? Here's how OEE works. For those of you not familiar with the term, I first start with my overall reporting, period, and within there, I say if everything was working perfectly, how much productivity would I get out with my expected planned manufacturing time? So I start with that. That's the 100%. Then I put multipliers in it. Availability. Is the machine actually running, or is the line running, or is there for some reason it stopped? It's not producing. That's the term. That's the availability quotient of it. So in this case, our example here, 91% of the time it was supposed to be running, it ran. I had unscheduled downtime for the other 9%. So I multiply by 0.91. Then I have how fast is this machine actually running versus its design speed, right? Now I can overspeed too. I can get greater than 100% in this area, but most of the time, speed is not always, it's variable. It could be plus or minus. Our example here, we've got 97% production rate. Then the last part of it is how much scrap we produced. So you can see the equation, and that's basically how we get OEE. So before I go back to that, let me just define here some of the aspects of safety as well. What is safety? These are the best definitions that we use, the general definitions of it. Safety is a freedom of unacceptable risk, made up of risk then is severity and probability. The acceptable risk, that's how we got back to this variability of it that we talked about earlier, right? So there's OEE, business performance, and then safety KPIs here on the left and right. And here's this balancing act. I got to give up one to get the other. That was the conventional wisdom. Now back to this study that turned all of that on its ear, right? Showing that OEE, you look at the top performers up here, a 90% OEE, if I use that equation here, compared to the average, the middle 50% in there. It's a major jump, 0.85 versus 0.9 in an OEE. If typically if you go to a plant manager and say, you know what, I can affect the OEE of this plant by 0.1% this year with this investment, typically companies would jump all over that. Even incremental fractions of a percentage of OEE could mean thousands, hundreds of thousands, maybe even millions or tens of millions of profitability from this site. So when we see a difference of 5 full points of OEE, there's something major going on. These are really excellent performers versus just the average, right? Now, if we look at the safety data on here, repeat accidents and industry frequency rate, I don't remember exactly how they were measuring that, but it was consistent across the entire. What did they, included an incident? I don't know if they included, near misses or anything like that, but it was consistent across. So basically, here's their safety ratings, and you can see a significant discrepancy here. But the real point here is that here you see the safest companies in the world up here by a lot, half the injury rate over the average, have a 5 to 7% higher OEE than just the average. So my correlation here is positive. It's not a give or take, right? I don't have to sacrifice. These companies are not sacrificing safety or productivity. They're demanding and getting both. So we started trying to understand, how are they going about doing that? Started studying that. Some of the consequences of what they were getting as well, and some of them were unintended consequences. And this is really how this contemporary idea of safety as a positive investment in the health of a manufacturing facility. These are some of the areas where they saw some positive growth aspects of it and positive elements to the manufacturing facility. On the negative side in here, it does require a little greater understanding of some sophisticated technology. So education of the staff, there's some shifts in culture that need to be done, and also some of the policies and procedures need to be altered in order to adopt some of this new technology. When I look at what happened, the results of this, so I'll go back to the early 70s, and what was society demanding from, I'll say, the machine safety industry, techniques, standards committees, manufacturers of technology and whatnot. Here's sort of the progression over time as to how did things start. And you can see in the early part of shortly after some of those rules and laws and stuff that were OSHA was put in place, demand for safety and some very simple solutions out there. A lot of it, involved guarding. The other major rule in there in safety, as you know, is lockout tagout. So I was surprised to learn that lockout tagout really didn't become law until the late 80s. September 1st, 1989 was the first time that 29 Code of Federal Regulations 1910.147, that's when that was signed or promulgated, was September 1st, 1989, but lately. So anyway, but you look at the rest of once society started, or manufacturing started putting these guards in there and say, what, this is expensive, it's cumbersome, started coming up with the inventions of some of these new techniques and technologies out here. Two-hand control, light curtains and stuff were invented in the 80s and 90s. So we started controlling access and making things a little more easy to access, and putting functional safety circuits in place. But it wasn't until some of the mid 2000s or so when we started getting into integrated manufacturing. And by integrated, we'll say the safety solutions were integrated into the manufacturing solutions. So in a control system, you had integrated safety rated PLCs, safety rated sensors, safety rated drives, valves, stuff like that. All that became part of the major, the general part of the machine. Okay. So let me move on to the next part of it here to keep things moving along. But manufacturing safety maturity, it's something that we came up with when I was at Rockwell to try to understand, how do I measure this? How do I make sense of this idea of how do these best-in-class companies, what exactly are they doing? What differentiates those best-in-class manufacturers from their peers? What are these top 20% doing in terms of causation? Here's our correlation study. Well, what are they doing from a causation? What do they look like? What are their general attributes? And this is basically where, you break it down into the very common people, policies, and technology. And so we look at this now. When we were at Rockwell, we tried to make this easy to understand or remember. We call it the 3 C's: culture, capital, and culture, compliance, and capital. But basically, this is what it is. It's the attitudes and behaviors. That's the cultural part of it. It's the policies and procedures. That's the compliance part. And then the technology and techniques was the third part. So what are the attributes in each one of those? So we started studying those and found 4 levels of, we'll call, manufacturing maturity in here. Level 1, the safety maturity index level 1, we characterize those types of companies as companies that really had very little interest in safety. They were really clinging to this idea that the only way to become safer is to sacrifice productivity. They firmly believed that. They weren't going to change their mind, and they were pretty much stuck in that. The next level up in terms of the understanding or the characterization were SMI 2s, Safety Maturity Index level 2s. These were companies that generally said, you know, we got to do something with safety here. They were primarily interested in compliance. And by compliance, it could better be said that they were really more interested in not getting caught. They were externally motivated to do what the absolute minimum of what it would take just to be compliant, or minimum to what to get caught, you know, not to get caught. There was a third level. These were company, the SMI threes. The SMI threes were typically companies that had experienced a safety incident, had measured the effects of it, not just the direct cost of a safety incident, but the indirect cost of the safety incidents. The significance of that is studies show that the indirect cost of safety incidents can be anywhere from 7 to 15 times the direct costs. Direct costs being the things that can show up in a spreadsheet: lost production, lost days, medical costs, increase in BWC or workman's comp claims and premiums or whatnot, things that you can actually show hard physical evidence of it. But 7 to 15 times that were the indirect costs, things that are very difficult to measure. That's employee morale, image of the company, value of the brand, the ability to attract and attain employees. Companies that study that said, wow, you know, the safety incident, you know, really costs us a lot more. So they said, boy, this is nothing more, you know, important than safety. Safety is number one. I'm going to sacrifice everything for the sake of safety, including productivity. Now, their safety KPIs were excellent. Their safety journey, they thought, hey, we've arrived, we're good. Our safety numbers are great. They think they're done. But what they didn't realize was that there was a level 4 out there. Companies that were attaining that in terms of safety, but refused to sacrifice productivity at the same time. So they were attaining both. That was the SMI 4s. Okay. The attributes in each one of those columns of that safety maturity index, the cultural part of it can be broken down by attitudes and accountability and commitment. I'll start at the bottom of the commitment part of it. Basically, there were safety committees with cross-functional safety committees that, you know, people were happy to be on and would take input from the factory floor and actually do something with it and address it. The accountability, you can see a number of them here. The most impactful element in here had to do with upper management being held accountable in terms of their compensation. When we saw that, we saw a significant increase in safety maturity level. Not surprising, right? The executives' bonuses were linked to however you want to measure safety KPIs. And then the attitude part of it was, you know, how do I get everybody from the top to the bottom interested and feeling like safety is part of their role. In the middle column part of it, called the compliance part of it, the policies and procedures, the things that we saw, the attributes in these top performing companies, basically was a direct correlation to safety maturity, was the degree in which particularly engineering and EHS collaborated. How well did they get along? How well did they work together? And how well did they come up with solutions addressing problems? How did they do that together? I'll also throw in operations as well. When we see these three working toward the same goal and having the same, you know, combining their charters, getting things out the door, engineering things for productivity, and then EHS for safety, we saw those elements working together. That drove the existence of policies and procedures, adherence to standards, and basically, you know, following the rules and having those rules in place and continuing to make them updated as well. The last one was technology. There's been significant, you know, change every day. You look, if you follow I'll even say the machine safety technology, you know, world, you'll see advancements in it. You'll see those reflected in revisions of standards to adopt new ideas, techniques, and technologies. They'll get vetted and tested out through ANSI and IFA in Europe and become reality. And then they're reflected in the standards as well. But companies that utilize that to help associates collaborate with manufacturing assets, that's the key. how do they continue and using technology to allow tasks to be completed uninhibited in a safe and continued productive manner. So that was the key, leveraging this technology. So that's how we got this matrix, 4 levels of those characterizations, and then the attributes within each one of those 3. If you looked at how the global market looked like in the, I'll say, the mid early 2000s, you'll see that the breakdown of the world was this across all 4 of those. Seeing that a good 65% plus 67% of the manufacturing was what we would generally term as machine safety immature, companies that were not proactively going after stuff, ignoring it, or just doing the absolute minimum. There are a few, the minority up here were, I guess, responding to societal demands, as well as, a vast minority of them were then doing something about it and taking advantage of advancements in technology. And that was reflected in the consumption of this technology that was out here too. As we project going out, through, what is vastly becoming present, but this growth curve, the characterizations and the makeup of the global manufacturing, mostly Europe and North America was the vast majority of the study group in here, with smatterings of Asia and Latin America in here. But this growth curve was simply a projection at the time, but it's actually on track. And you can see kind of the explosion of the demand of companies saying, I refuse to sacrifice safety or productivity. I want both. And more examples of companies seeing that. If you want to see where you stand today, there's actually a free tool that we created when I was at Rockwell, is the Safety Maturity Index Assessment Tool. You can search on that, Rockwell Automation Manufacturing Safety, Rockwell Automation Safety Maturity Index. You'll get a link in here. It punches you out to an external page by another consultant called MPI, but name and email, and you can answer questions and get the results. I'll ask 5 questions on your behavior, your culture, 5 questions on policies and procedures, and 5 questions on technology and techniques. Highly engineered. I'll tell you, we took a lot of time and effort to make it this whole huge, deep topic digestible. But you'll get actually some numbers. There'll be some other demographic questions that'll be asked, because you're going to be able to benchmark your organization later and compare yourself to others in different industries or even within your own industry. So I can assure you, I was the one who developed this whole idea, and I can assure you it's totally anonymous too. There's no correlation between your email address and the answers that you give. It all gets thrown into a general bucket. There's no way to connect it. But you'll get a report, basically, that will allow you to get an overall safety maturity number, as well as numbers within each one of those columns. Now, why is this important? Why is it important to have numbers? In my experience, the higher you go in an organization, the simpler the message has to be. And this is a very complex and broad, with lots of context, the question, how safe are we? How do we look here? It's very difficult to answer that in the amount of time, I'll say the attention that an executive can put on this if he's just getting into it, or she's getting into it. So using numbers, that is the universal number, or universal language is numbers. So they decide to enumerate, this concept of safety maturity so that companies could understand it. So, and allow you to compare yourself. So what you'll be able to do if you do this assessment, it's free, it's just you do it yourself, but you can break this down and take a look and compare yourself by different industries. Say you're a tire company, you want to compare yourself to the food companies out there, or tire company compared yourself to automotive industries. Geographic regions, I want to see, hey, how we look compared to Asia or Latin America. Size of the company, years of operations. So you can get actually a comparison of that and play with that as you do it. So it's a neat little tool. If we go back to that D plus V plus S greater than R, this is one of the S's. This is one of the first steps. This is a key first step you could do, on your own, and produce these numbers and share it with your executives and say, hey, look, we've got some issues here. Here's another idea too. You can do this across company as well. So say you got 3 facilities, you could do this at each of the 3 facilities. Another idea is to do it at different levels within your company. If you're curious about the discrepancy of attitudes and behaviors and whatnot from your top of your company to the bottom, have your plant manager, have the head of engineering, have head of maintenance, have a maintenance person, have an operator, machine operator, have, a forklift driver answer these questions as well, and then compare the reports and see if you've got a discrepancy from the top to the bottom. So let me just talk real briefly about another tool that you've got available too, if you want to get an idea about, how do I justify this stuff? There is an ROI tool that we produced when I was at Rockwell to begin to how do I justify the use of this technology? How do I get started so I can begin to see some of these positive results? And where you'd start, consider and maybe talk to your manufacturing associates, maintenance people, engineers, and try to find, I'll say, maybe a pilot project or some idea. Begin to ask some of these questions here. Where is my current safety solutions impeding productivity? They may make me safer, but is it the best solution out there? Are we sacrificing productivity for safety? And what can be done about it? So then you come up with, hey, what can be done about it? What can I do to maybe overcome areas where my safety solution is being cheated or defeated in here too? Begin to ask questions about the solution that's there. Is that the most effective way to go do that? So with that, you pull in some experts, you talk about some ideas, and say you come up with a solution to say, wow, okay, we could do it differently here. How do I justify the investment in that? So another tool that is at the Rockwell sites as well from my previous role, but is an ROI tool. And the unique thing about this ROI tool, and even OSHA, there's a bunch of safety ROI tools that are out there. The one that made this one different is that the calculator calculates not just what your finance people call the cost avoidance, the safety piece. If I avoid a safety incident, here's how much we'll save. Here's the justification there. But it combines it with improvements in OEE, with productivity. So bottom line is you can generate a report. The neat thing about it is it's got some defaults in there. If you don't know your own numbers about, for instance, how much downtime you have, you can take a guess at stuff, but it'll start with some of that stuff. How much is manufacturing cost for this production line or this machine? How valuable is this machine when it's running? How much money do you make in 1 hour production for this machine? So you can throw some numbers in here, answer all these questions in here, say, okay, how much am I going to invest in this project? And then get the injury costs, direct and indirect costs, but then it also calculate the improvements in OEE as well. So here's in this example, the return on investment was close to 400%. So in other words, in 3 months, the payback was 3 months. The rest of the year, boy, we're doing great. The total benefit of both safety and productivity for that year, I invested $75,000. I got close to $300,000 in value. What this report then gets you is that when it comes time for the annual review and budgets, you've got a stack of 33 potential projects, capital improvement projects for the place. How do you sort those out? Most of them are going to be justified purely on OEE, and that may be just fine for you to come up with the 3 or 4 or 6 that you're able to actually do and implement. But throw this one in the mix and say, hey, this is one where I'm going to get both safety and productivity. If your executive has some sort of charter in there that says I need to improve on both of those, here's a project that's been justified in both of them. Okay. So with that, just to wrap up, just some ideas, some of the things that we talked about here before putting the subsequent parts of this seminar here, into context. But this is basically the summary. The contemporary view of manufacturing safety out there is that the safest companies in the world are the most productive, and there's evidence to show that. It has far-reaching effects on the image of the company and your ability to attract employees and keep people working. As we all know, I've never seen so many hiring signs and flags and efforts to bring people, particularly in the manufacturing realm. We talked to steel mills and stuff, and we asked, how many openings do you have right now? One of them told us 39. They could hire 39 people tomorrow to come work in a steel mill. They're struggling to keep people in there. And then at the higher value, the aspect of this concept of corporate social responsibility is a growing, concept out there, be it across environmental, ethical, diversity, how we treat our employees, should be, a value and a part of that corporate social responsibility. Okay, so next week we'll carry on. We'll put this in some of the rules, the regulations, what it takes to be compliant into this context of what we just talked about here, and then subsequently after that we'll talk about some of the techniques and some of the more details in there. So sorry, I ran through that real quick. I think we got started a little bit late, and I wanted to get all this content in here. Nick, I guess we'll open it up for questions for those that want to, stay on. I'm happy to stay on as long as you want. We can answer those live now if there's anybody still listening.
All right. Well, it looks like we still have a lot of people in here. No specific questions were submitted, but I want to first say, wow, there was a lot of information to take in all at once. Yeah. I think this is something that a lot of people need to help move their safety programs along, especially the small to mid-sized companies who have often preached, well, safety does pay. Well, how? And you've started to put some numbers to that. Heather just commented, thank you so much. Great information. So I think this is going to help our members start to identify how to measure and how to sell safety. That's one thing we have to do as either an HR person or a safety person is we're a salesman too. And we got to know how to sell this safety to leadership.
Yeah, hopefully some of this content can help you, use as much of it as you want in your internal sales efforts to get the point across.
Yeah, I will say this has given me some great ideas as I took notes throughout the whole thing of how I can change even some of the consulting I'm doing for companies here in Northeast Ohio and help them sell to senior management where we need to be to reduce their overall cost.
Very good.
Mark, I do have a question. You may have touched on this a little bit, but is there a difference in the size of companies? In the higher level companies with the higher performance, was a certain employees with 500 or more, 1,000 or more? Was there any? Was the research kind of broken up for size, or because it seems like a lot of the smaller companies may be more in that bottom, just barely making it by that 5% scale you had in your one chart?
Yeah, I don't have the data, to answer that definitively. I can say that, larger companies, by and large, companies that I'll put it this way. The companies that were most interested in corporate image seem to have, that was the main driver. Those are the ones that they had the impetus and the motivation to do something about this, to protect themselves. One of the things they did at Rockwell as well was they came up with an award. I don't know if they're still doing it since I left, but Manufacturing Safety Excellence Award. And that was won by large global multinational corporations, as well as some very small companies, as well as there was another version of the award that was recognizing individual plants within a large global, multi-site location where one plant was outperforming and meeting the threshold, even though the other elements of the company were not. So size doesn't really matter in this regard. It might show up in the data that larger corporations are doing, but it's also much more cumbersome for them to implement this stuff nationwide. It's one of the things that myself and my staff did was help with the adoption of some of this technology. And we said, well, you can't really adopt this technology until you have the policies and procedures and standards in place. You're not going to have that in place until the culture is ready to adopt the technology, techniques, policies, and procedures. It was so that SMI concept, it was really all intertwined. It's easier to transform a smaller single site location, toggle the bits and minds of everybody in the place. So we could see transformations happening much more rapidly the smaller they were. And all of the aspects this technology was applicable, to the smaller ones as well as the larger ones. I will tell you, there was one demographic here when we think about companies that operate in an industry where margins are larger or smaller, right? Then the question, can they afford to do this stuff? And the argument was, the ones that can afford it, that were very successful, high margin industries and out there, they could afford to do it and they just did it, right? Mostly driven by company image. But the argument was also the companies that operate in very narrow margins have a higher justification to pursue an industrial transformation like this because they can't afford one safety incident can put the entire enterprise out of business. And we saw that happening, throughout industry. One incident, right? And you never know when that's going to happen or where it's going to happen. So the narrower the margin is, the more careful companies had to be. They had to take advantage of every opportunity they can to outsmart their competitors and differentiate themselves. So the companies that did that, really, you can see if you go back to that Aberdeen report. I mean, if you had a company in narrow margins and a 5% difference in OEE, you're going to be kicking some butt in that narrow margin industry and driving competitors out of business. With that level of difference. So that was another. I guess I'm infusing another question in there is about margins and stuff and size and stuff, but all of it's applicable regardless of geography, size, age of the company, and whatnot. Yeah. Now, age of the company. That was we just had a nice conversation with a manufacturer yesterday about this. A plant built in 1996. They have people that are original employees when the plant opened. So that because this is how we've always done it there, they go all the way back to 96 when a lot of this technology wasn't available, techniques weren't there, the standards were old. They were hampered by older employees that weren't ready to toggle over. And they're starting to see a transformation, as those people are retiring or leave the workforce and younger people come in that are more open to other technologies. Their transformation is actually starting because of, they're getting rid of some of the older experienced people that were kind of stuck in the past.
That's something Nick and I always talk about. Safety, there are some obviously short-term things we need to address, but having the long path, the long view, especially when it comes to that cultural piece, that could be a very slow process. Sometimes if there's an acquisition or merger, you could kind of switch gears a little quicker, but it could take decades, and that's why that small incremental change is so important.
Now, I'll refer you to Paul O'Neill, 1987, Alcoa Corporation. If you've read, you can read all about Paul O'Neill, this new CEO of Alcoa in 1987. Alcoa was basically going out of business. There wasn't much hope for them. They had to stick forward. They could see they were losing altitude and they were about ready to plunge. And the very first statement out of his, I'll say, inaugural address, his introduction speech was, "Hi, I'm Paul O'Neill, and I want to talk to you about manufacturing safety or safety for the employees." I can't remember the exact words, but his entire speech was all about safety. And he finished it. And he's to an audience of Wall Street analysts going like, "What are you going to do to save this company? You're going to restructure it. You're going to close plants. You're going to finance the debt." Well, no, I'm just going to talk about safety. That's it. So the point about all of that is that, culture will drive the policies and procedures and technology. Culture starts at the very tippy top of the company. It will be a reflection of who's running it at the very top, board of directors, CEO. So toggle the bit up there, and transformation will very much quickly, be changing, and being adopted, much quicker than if you've got, the very top, you're going to be hampered, by by somebody that doesn't agree. But culture will drive it, and the top drives the culture.
All right.
right,
Well,
Nick.
once again, Mark, thank you so much for doing this today, putting on this presentation. It was great. So much information to
Yeah.
digest here. And I'm excited to see how parts 4 through 5 add into this. And I know as we get into more of the technical aspects and the more of the bits of what we're going to deal with, I know for myself, I have questions, and I'm sure we'll have lots of questions from our membership too, as we get into more technical aspects.
Yeah, and if I know we went through this, really fast. This is a full day workshop. We're going to put into 5 1-hour segments. So I fly through this pretty quick. You got my contact information here. I'm happy to, just chat on the phone. If you got any questions about any of this, applications or, or concepts, or you want to throw a bullshit flag, give me a call. You're full of it. I'm happy to have that conversation. I'm always open to new ideas.
All right. Well, thank you again. Thank you to our members for being here. And we look forward to seeing everyone next week. Until then, everyone, please be safe.